Hey, hi Kapil. Nice to meet you. Kapil, what? So, I come from Jabalpur, Madhya Pradesh. Um, Born in Bali, Uttar Pradesh, brought up in Jabalpur, Madhya Pradesh. And I've graduated from IIT Kharagpur with a dual degree, Bachelor's in Civil Engineering and Master's in AI and Machine Learning and Applications. And currently, I'm working with American Express as an analyst data science, where I validate um, classical machine learning models for the use case of marketing. I work with MRMG in the model risk management group, where I build challenger models on a regular basis, and where I build challenger models that ultimately beat the performance of the modeling team. नहीं ये नहीं बोलना है, ये डिफेंड नहीं कर पाऊंगा. So my day-to-day task is to find critical gaps in the model built for a business use case for the modeling team, and make corrections to it by building a challenger model and showing the modeling team that we can do it in a better way. This is one. Apart from this, the regular business as usual include model validations as well as annual reviews for the models that go that are triggered at an annual basis. So I have currently validated around 22 models in annual reviews, um, four full scope model validations, and which take around 30 days each, and 18 limited scope validations that take around 15 days. So this has been the experience that I have. So I have a fair bit of understanding of what is the business context around credit cards for the marketing perspective, for sure. Coming from the credit abuse perspective, I do know a little bit. No, don't, don't, don't. I do know that there are gamer models that are used in American Express to identify people who uh, are gamers. Basically, gamers are people who get the card, who do everything right to get the card, and then ultimately they have a tendency to either utilize the bonus and then um, stop using the card, or maybe just utilize the bonus that was their purpose. So this is one of the applications, or this is one of the segments which I can think of, which comes under credit abuse. Right. Hmm. Hmm. Perfectly aligned. Aligned, Kapil. Hmm. But what I also think is, just doubling down on what you said right now. What I also think is that hmm. So majorly, I worked upon two different aspects. One is the business as usual that takes up the majority of the time that I spend with MX, and the other project that I was a part of is the independent model validation tool. We call it metric over here, and the I'll explain both of these one by one. Firstly, the business as usual part. Um, there were two aspects. There were two major aspects. So, the model validation journey, or the model risk management in general, functions by regular identification of critical risk areas that affect the business as well as the reputation of American Express with the customers in the market. So there are two types of models. There are two types of customers that I have dealt with in my experience at Amex. One is the consumers, the direct consumers, the people who have the credit card in hand for them for their own use. And the second is the commercial consumers, commercial customers, people who have American Express credit card and they use it for their business, small business or a global commercial uh, business. So while dealing with these two types of customers and the marketing models related to those customers, I had to validate full scope models. I had to validate limited scope models. So scope is decided by the independent model validation procedures over here. Let's say there is a small change in the model. So we will not be spending a lot of time validating the entire model again, whether that particular change is um so significant that we spend 25 days on this. So that comes under limited scope. Don't say this. Okay. So the limited scope models are models that affect one or two areas of the model. Those are significant areas, and they can affect the model and the business impact in a significant way. But these are just in quantity two or three. So that's why we call it limited. Whereas a full scope change involves more than 7 to 8 areas. There are 12 in total areas that are there. If I just quickly pointed out that there is a process verification, there is data, there is data quality, there is performance, there is hyperparameter tuning, there is assumptions and limitations, the ongoing monitoring of all these models, there is implementation, the business impact, which is the incremental revenue that this model is bringing. So these are all different areas, and all these different areas, if more than 4 to 5 of them get affected, which is significant as per the IMVP, which is the independent model validation procedures, then we call it a material change, and that actually hits the bottom line of American Express. So if anything goes wrong, if this model does not perform as intended, then that will hit the bottom line. So as I mentioned that I've validated around you know I have assessed 20 annual reviews up until now, which has impacted $103 million in the bottom line. And I have also validated now four. Earlier, when I wrote those, uh, I wrote that in the CV, there were only three, but now there are four models. So the two models So the two models are $3.8 million in the incremental revenue, uh, and this is what annual review. So during annual reviews, what we do is so there are two aspects: annual reviews and model validation. In model validation, it is the regular business as usual activity that we do in MRMG, model risk management. The modeling team builds the model. It comes to MRMG to find critical gaps in the model, which we do a lot. We also build challenger models to help the modeling team revisit whether they have actually whether they have actually entailed all the necessary aspects to build that model. We try to build a better model than them on the performance metrics, and if we do so, the model is rejected. Once the model is rejected, the modeling team takes more time. They build a better model. So this is actually in a way helping the enterprise reduce, mitigate the risk in monetary as well as reputational terms. This is the regular work that we do. This is a high level view of what we do. I can go in detail if we want to. Next, annual reviews. All these models that are there in production, 110 as of date for marketing purposes, all these models require regular annual check. And all these annual checks are on different aspects of the model, whether the data is still right or not, whether the process the modeling team is following is right or not, whether the performance is as per expectations or not, whether the hyperparameter tuning process is as per expectations or not, whether the model interpretability is as per expectations or not. So all these different aspects we validate. Once validated, the model is still either rejected or is sent into revalidation, that we need to revalidate it or you need to revisit the model. We give them findings that okay, this is a finding that your model lacks in this aspect, and then they try to remediate and close the finding by providing us mitigation action plans. This is what we do. Now, apart from this, the business project that I have dealt with, there are automation projects to automate this entire workflow that all the analysts do on a day-to-day basis. One of the automation projects that I was involved in was independent model validation tool named Metric. Now it aids in model validation. How? We have to check manually at the moment that what is developer tool to enable independent model testing of model input data and outcomes, comprising two core models, 14 submodules, based on model validation time calculation. Implemented 7 input data testing modules. Implemented 7 input data testing modules to evaluate data reliability, covering variable stability, variable correlation, dependent independent relationships, variable target relationships, variable representativeness, impacting 47% of model outage. Tested uh, outcome testing modules to ensure model robustness and accuracy, including rank ordering, model error analysis, stability checks, sensitivity and resilience testing, responsiveness analysis, swap set comparisons. All right. So, so in the process of building this business project that I did, I was involved in building the pipeline for. I was involved in building the data side of things. How do we test whether the input data is correct or not? So for that, I have built um out of seven, four different modules on data, which is on testing data, which is data reliability, covering variable stability. How do we test variable stability? So there are four scores here at Amex. Let me not go into the details of it because this would be PII, but we test the variable mean, whether the variable has shifted, whether the variable in comparison to another benchmark variable or benchmark timeline has shifted, benchmark vintage has shifted in terms of mean, in terms of distribution, in terms of um, mean, distribution, extreme values, percentage missing data. Okay. Now, once we do this, once we are satisfied that once we are satisfied that this data, this particular variable is good to go, we do that for all the variables in the model that the modeling team is using. Now the model passes the data reliability test or the variable stability test. For data, we do this test. For variable stability, for variable correlation, we independently have coded an independent module where the analysts, they just have to put in all the variables that are being used as well as the data, of course, and they just have to run a Python command and they will get the correlation matrix. Now, the dependent and independent relationships, how do we judge that? That is judged by the confusion matrix. That is one. That is also judged by the Rankin plots, the RNP curves, the variable target relationships, and variable representativeness. The variable and the dependent and the target relationship and the variable representativeness. इसको अच्छे से बोलो यार, एक स्टोरी होनी चाहिए बस. If I give you a data in a tabular form, how will you test its reliability? Context, survey data, experimental data. Identify variable types. For multiple predictors together, So variable representativeness means checking whether the distribution of a variable in your dataset properly reflects the real world population or the target market for which you want to build the credit card marketing model. If a variable is not representative, the model can become biased and fail when deployed. Here's how I would test variable representativeness step by step. Define what representativeness means. A variable is representative if its distribution is in the sample matches the population or business target segment. There is no sampling bias. Example, all data for a single city when targeting nationwide, no over or under representation of certain categories or ranges. Example, all high income customers only. Okay, so I tested outcomes. So in this particular project, uh, the aim was to achieve automation. When we are validating a model, we have to do many subtasks, many different other tasks in order to check whether the data that the modeling team is using is appropriate or not. And there are multiple different benchmarks that we set, multiple different avenues that we test to ultimately understand that the data that the modeling team is using is actually perfect. So I worked upon these models, the data model, and my team worked upon the performance checking model, and and all these different modules, which is for data reliability, covering variable stability, variable correlation, moderate dependent independent relationship. So all these different modules, right? So data reliability, variable stability, variable correlation, dependent independent relationships, variable target relationships. We applied statistical tests. Don't say. So so all these were coded in Python, and now all this is just at the click of a button now that we can do. So let's say for data reliability, um, we check that how much percentage missing value is there, and we check whether the data is imbalanced, how much imbalanced, whether it is imbalanced beyond what could be modeled or what could be balanced for, whether the population coverage is appropriate or not. That comes under the reliability of the data. Then we check that for variable stability, or whether that particular variable is categorical or numerical. If it is a numerical variable, we check the PSI value in terms of vintage. Let's say for two different vintages, for an older vintage and a new vintage, the variable has shifted in terms of mean, whether that's what the purpose of PSI test is. So we do that. And for categorical variables, we do chi-square test. For variable correlation, if it is numerical, we do Pearson correlation, and we do chi-square test for categorical variable. For dependent independent relationship, we do t-test for numerical variable, univariate analysis, and chi-square test for categorical. And for variable representativeness, we do population distribution and chi-square test. Now the third is an independent project. Um, it is a supervised project and is yet to receive approval from the senior leadership. So that's why I have written it separately. So in this particular project, I tried automating the regular post implementation verification process. Now, so recently we encountered that the modeling team was not adhering to the principles or the policies to ultimately implement exactly those hyperparameters which MRMG has certified. Mistakenly, their model file or their code, which got implemented, had extra hyperparameters, and this was found across 3 to 4 different models in their inventory. Now, this is a major risk area that we don't know whether the model that is in implementation will perform as intended. But we don't know. We we don't know whether the model will perform as intended or not. So what we did is we issued a finding, and secondly we started developing an independent model testing capability where it is already a part of our procedure. Post implementation verification, once the model went into production, MRNG checks whether only that particular model file, which is the code, went into production or not. But that we do only for a small section and a representative section of models of different categories in marketing. That was not being done for the entire inventory, right? So this is not just so this 9 to 100% includes the in-house models as well as the vendor models as well. So I used the latest technology using Crew AI based agentic AI framework, which is basically agents that are based out of roles, and all those roles which the agents are based on which the agents are made. Though I created a workflow for that, where just we can just directly put in the data, we can directly put in the code, and then it will immediately tell us that the model file which is in implementation, as well as we can directly put in the model document, which is this is what they have documented, and we can check whether this particular thing is actually happening or not. So this solves problem at 2 stages. One, it is efficient. It is efficient at analyst level. Now, analysts can do more other important work, which is find critical gaps, critical thinking, and this is just implementation testing, whether this is equal to this or not. And it gives control to MRMG that the model which went into production is not a risky model. There is no risk related to model, and this mitigates the risk. So, model risk management ultimately. Optimize Facebook's Robin marketing mix model across 5 ad channels, boosting attribution, accuracy, ROI measurement, modularized model code for faster front-end integration, reducing deployment time and improving scalability, tuned hyperparameters, alpha 0 to 0.3, gamma 0 to 0.5 to enhance model accuracy in hill curve fitting, improved simulation accuracy from 45 to 87% via advanced feature engineering, binning upsampling, researches, feature engineering library, improves simulation accuracy, designed machine learning pipeline reducing total experiment time by 33% overall, evaluated multiple ML algorithms across diverse datasets enhancing model robustness, reliability, and generalization.